Okay, let's go. Let's start. Yeah, thanks for having me. The first time speaking at a different local conference. I've given this talk in a different local meetup before. So compared to the previous talk, I think this is going to be very basic. So let me know if you think this is like literally like very basic. Then I can talk about some of the other stuff that we've done, or I can like notch up the level a bit. But in this talk, what I want to talk about is how can we use functional programming in Go. So Go is not really like a pure function language as such compared to a bunch of other functional languages, but the principles of functional programming, like higher order functions, currying, etc., like immutability, etc., are super useful. And I want to sort of touch upon just one of the concept right now, which is uh, like understanding of higher order functions, right? Which is functions as first class citizens, essentially. So just for a bit of context, like I run a company called 1 to N. I hope you're able to see my mouse as well. So we specialize in Go, use cloud native tools, etc. Uh, Focused on like site reliability and backend engineering. So that's where I got interested in Go and went down the rabbit hole as such. All right, so that's the idea. What I've done is I've been working on building a bootcamp. So we'll try and do live coding this time. Let's see how it goes. I've built a bootcamp for Go, which I make sure that all of the engineers who work with us go through. So that's like this bootcamp where we have bunch of like examples and projects that we build. So this is one of the projects, right? There's some basic like how do you deal with structs and functions and basic stuff like that. And then there is a bit more advanced stuff related to building CLIs in Go, like grep, tree, word count, like the classic good old Linux CLIs. How do we build that in Go? We talked about that. Currently, what I'm working on is something a bit more advanced, which is like how do we build like a key value TB in Go, right from scratch. What all would it take? Touching upon the TCP levels, the networking, the multiple Go routines accessing on the server side. How do you protect the state, etc. Then there's another problem that I'm working on, which is similar to the open source tool, but trying to do that in Go to just to see how it goes, right? Uh, yeah. I would really appreciate if there's any feedback. Like, do you want me to? So this is a problem that I'm going to cover. Otherwise, let me just do this. Like, I'll cover one or two stories, and I would like you guys to tell me, hey, this is too boring or too slow or too simple. Uh, then I'll change the notch a bit because this was the talk that I'd given at one of the local meetups where the audience was sort of new to Go and in general programming, right? So if all of us here are sort of pretty pros, then I can notch up a level a bit, right? But regardless, what we have here is like imagine like a bunch of numbers, say 1 to 10. We want to filter out and get only the even numbers from the list. Like very basic, simple problem statement. So we'll try and do test-driven development in Go. So I've started like already written some tests instead of wasting a lot of time. So there is a basic test where you have a bunch of numbers, and what we want is only the even numbers, right? So let's say there's a function that we write where we pass this nums, and we get something back. We expect that it should be this, right? So let me try and run the test. It's going to fail because there's nothing being returned here. Um, and you can imagine the logic would be, hey, iterate through this nums, just range over them and find out if one of the numbers is even. If yes, then add it to some sort of output array or output list and then return that output, right? So that's what we have here. I'm just going to uncomment the code and see that this passes, right? So this so far with me, like here's a basic, like a very basic number filtering. Given the numbers, give me just the even numbers from the list. So there's that filtering condition. All right. What's the next thing? So now we have okay, the same input, but we want to know odd numbers from the list. So that would be easy, right? Let's just, again, if we do it from a test driven point of view, we can just do this. Hey, give me the odd numbers. And instead of that, I need this. And probably I can just do filter odds, maybe. And can I duplicate the code for now? Let's see where it takes us, right? And the only change that I have to do over here is, and it's not like there is a remainder, right? And if I run this, it should pass. Yep. Okay. But what we can see is right now we already see some duplication of the code. But yeah, okay. Let's keep going. The third story is about having a prime numbers now. So the ordeal is similar. We kind of do the same thing where instead of odd, now we need prime numbers. So I'm going to do something similar. And the primes are say 2, 3, 5, and 7. Right? And here you have like filter odds, filter primes. Now I don't know about you, but I can't write a prime number program, especially live code that. So I'm just going to copy paste something which returns a prime number, and hopefully that works. So it's just a standard prime function. Oops. Yeah, this should work. And if we run the test now, okay, we got the prime numbers. So what we're trying to do is every time we're iterating through the nums, figuring out if that num matches a particular criteria, which is say is prime, odd, even. If yes, then add it to the list and return the output. Right? That seems to be the theme so far. So let's look at the story 4. Uh, by the way, before I proceed, is this sort of too simple, or is that okay? Like, can I continue with this thing? Just some nod, some message would be super useful.
Yeah, just go ahead. All good.
Okay, cool. All right, cool. Then what we have is the next is a bit interesting, where we don't need just one type of number, but we need odd primes, right? So odd primes, like you just drop 2, all the other numbers are odd primes. Let's see how we can do that, right? So now at this point, what I'll do is I'll just modify this program itself to make it easier so that I don't waste a lot of time in writing a lot of code. So imagine we just refactor this to be odd prime, and I change this method saying, hey, I want to get odd primes. Now, in odd prime, what I need is I need this to be prime as well as I need this to be not even, right? So I'm going to do like a and here, something like this. And if I did that, this should work. All right. Okay. So far, so good. Then let's look at the next one, which is now they're talking about, okay, we need a even multiple of 5 from the list. So imagine like 1 to 20, even multiples of 5 are essentially multiples of 10. So you've got 10 and 20. All right. So it's kind of same as before, but 2 different conditions added together. For the lack of time, I'll just probably skip this, but we'll move forward with the next story and see where it takes us. We have odd and multiples of 3 greater than 10 from the list. So it's not just 2 conditions, it can be many conditions, right? Again, I'll just get to the crux real quick, and then let's look at the next story, which is where it talks about I need to be able to specify a bunch of conditions. Like it would be odd, even, greater than 5, multiple of 3, prime. It couldn't be any conditions that can be given by user, right? And I need to be able to write a program to filter the numbers that match all the conditions. Like they have to be ANDed together almost. right? So far, if you look at this, we've got odd filters, odd primes, which is ending the two conditions, like whether the number is prime and whether it's also odd. What we want is we want to extract this part out into some sort of mechanism where we can let user pass these conditions and we just apply them one after the other, right? And we AND them all together. So if you think about it, this is a classical like a function. If you've used functional programming, this is a classical like filter problem. So what we're going to do is I'll just directly jump to this story and we'll try and write code for that, right? So let me just again copy paste the test case for now. And I'll say, hey, I want to write, let's say this odd greater than 5 multiple of 3. Let's try and write that, right? So I'm going to say, okay, I need odd greater than 5 multiples of 3. All right. So again, we have numbers from 1 to 20 instead of 1 to 10. Okay, and we got 9 and 15, right, as the output here. These are all the odd numbers which are greater than 5 and multiples of 3. Okay, so let's see. So instead of now writing a generic, instead of writing a specific condition just for that, why don't we create a filter like all, right, where we pass these conditions somehow. Now these conditions, how do we represent them, right? Like these are almost like, if you look at it, these are functions like odd, greater than 5, multiple of 3. These are higher order functions, right? So one way we can do is, wouldn't it be ideal to specify something like this, like odd greater than 5 and multiples of say 3? That would be really cool interface to get, right? Like here, filter all the numbers which are odd, greater than 5, multiple of 3. What would it take us to do that, right? We would need some function. So let's start defining that. So odd becomes a func that takes an int and returns a bool. And this becomes a higher order function where we take the n and we check if it is odd or not, right? So this right here, %2, yep, this right here is a function which takes a number n and tells you whether it's odd. You're not executing it here, you're just passing it as a reference. So it's as good as storing it in a data variable, like we pass arrays and simple characters and strings and runes. It's exactly a matter of doing that, right? So similarly, let's try and define this greater than 5. Obviously, we can also do something like this, like it's a function that takes an n and checks whether it's greater than 5, right? That becomes my greater than 5 function. Similarly, multiple of 3 would be very similar to that, except it's going to be 3 here, right? Imagine if we can create an interface like that. So let's start creating a func, like maybe copy paste this for now again, and let's create like a filter all, which takes nums and it takes like set of conditions, right? So how do we take that? So it's a func which takes a num, returns a bool, and we call it, let's say, conditions, so cons, right? And we need like okay, how do you, yeah, filter all, and oh, okay, I have got it over. Oh yeah, okay, cool. So what oh, that's my bad. Let's go to the test here.
Try putting the dots.
before func instead of cons.
Oh, yeah. Correct. Awesome. Thanks for that. That's correct. The syntax always gets me. Cool. All right. Yeah, so we've got a filter all, which takes a bunch of conditions. Well, what you could also do is, if this feels like, what the hell is that? Like, what's the syntax here? We could always do something like a type alias in some ways, where we can create type condition, could be a func of like which takes an int and bool, right? And we could just say, hey, this is easier to read instead of that, and that also works. So it's almost like a aliasing saying, hey, this is a type. Just define a good custom type so that it's easier to read and reason with about the code. So let's do that. So that's how we can do. And again, you can just do, instead of doing that, you can just say, hey, this is a type is condition, right? Something like that. Like you can do it to be a condition type if you have to. All right, so we've got this filter. Let's we don't have the output yet. So what we need is, we need to be able to iterate through the numbers. For each number, we need to run through all the conditions, right? So let's try and do that. So hey, here is a num, and now this is where we need to kind of do another iteration, which is say for or in the cons condition. So there's this condition. Now what we need to do is, if we actually get this condition on n, if it matches, then what? Do we add it to the output? Well, not really, right? Because the next condition could fail. So what we need is a opposite almost, right? So something like this, that we need, hey, for every number, see if it matches all the conditions, right? So I'm going to have a bool called all matches. I'm going to have it as false by default. All right. And I'm going to say, if a condition matches, if it doesn't match, then just say all matches equal to false. Actually, let's start with true here then, right? So it's going to range over the conditions. For each condition, it's going to apply that num. If it is all matches, if any of the condition doesn't match, it's going to return false, and we could even break the loop here if we have to. And then here, instead of that, here we check if all matches, only then you append the output. Otherwise, you don't append the output, right? And this loop goes through for every number. Now, notice that this is almost like a short circuit, right? Like if the first number, let's say number 1, is it odd? Yes, it's odd. So it's going to go with the next condition. Is it greater than 5? No, it's not greater than 5. Then in that case, the all matches will be false, and we won't actually check whether the number is multiple of 3 or not, because it's almost like a short circuit operator, right? So let's see if this runs. Okay. Of course. Did I do it correctly? Some error. So say got this, we want 9 and 15. We
Your
want odd
multiples of
multiple.
Your multiples of 3 should be a double equals and 0.
Yeah, perfect. Okay, yep. That's the problem with live coding. Cool. All right, we got it. So what we just did is, we wrote a filter, a generic filter, which can filter any nums on any conditions. Isn't that great, right? We could do further. We can do this using Go's generics if we want to, instead of just making it work on numbers, we can just generify this type, and it can also work on any data types which can be filterable. So imagine, like, I want strings, I want customers, I want orders. You can filter them by any condition, and all of this is kind of generic in some way. Obviously in Go, we try to have a balance of too much generics and the code that actually reads simple and just does the job. So that's where you need to kind of have the balance. But the idea of this is, what I wanted to show was, hey, here is a way to write a higher order function which takes input either the functions in this case, or it returns a function, right? That's a very powerful concept to know and understand. We could do one more thing here is imagine like I have to write multiple of 7, right? What I would end up doing is I would end up repeating the same function. Then okay, multiple of like 11. Okay, fine, I'll do 11 again, right? That's quickly going to get boring. So instead, what we could also do is we could create a generic function here. By generic, I mean you could say, hey, I need multiples of n. I'm going to pass the n over here, right? So you could say, hey, I need a func that takes the like the n here, or the num, let me call it num, actually let's call it n, and then we call this one num. Might be easier that way, right? So we need we need multiple of n, and what this does is it returns a func here. So this returns a func, and you got something that looks like this. Let's see, this is very bad looking for a single line, so let me try and fix it in 2 lines, I guess. Yeah, I'll just close this for now. Right, so if you look at this, we have okay, let's do it this way, then it'll be easier to read. Right, what we have, and this becomes again a higher order function which we can use to define multiples of 3, 7, 11, and what have you, right? For example, let's show you how. So we could do multiples of n and just pass 3 here, and I could do multiples of 7 and I could just pass 7 here, and multiples of 11, no problem, and pass 11 here. What is happening here is that this n is this 3, 7, 11, and this is a higher order function that returns a func here, which takes this num, whatever the num, and checks whether, of course, we have to do it over, we have to do this num percent n. Right? This will work. Let's see if this works. Let's try that. So we've defined multiple of 3 as a generic, and not generic, but in a way, in a higher order function, and yeah, still works. So this is kind of a way to do higher order things essentially. We can do one more if you want, or for now I think I'll just skip it. So I'll just talk about what it is. So imagine another case where we have these many conditions, but instead of and we have an or. So it's a short circuit or operator, right? Where imagine this, like I want primes, or I want numbers that are greater than 15, or I want any multiples of 5. So you're going to get all primes here. You're also going to get all numbers which are greater than 15. So you get 16, 17, 18, 19, 20, and you get all multiples of 5. So like 5, 10, 15, 20. You could imagine to write something like this, we could do something very similar, which is, hey, instead of saying filter all, we could do filter any. And instead of we just switch these operators. Like we just say, hey, instead of, say, for example, you can do filter any, and it matches any conditions. So we can do, instead of saying all match, we can say, hey, this is any matches, right? And by default, any matches are false. And the moment something matches, you say any match is equal to true. Yep. As soon as any of the condition matches, you want to break out of the loop. You don't need to check the next conditions. And as soon as there is any matches, you would add that number to the output, right? These two functions are very suspiciously very, very similar in terms of the way they work, but they're generic in a sense that they can operate on any ints here. Obviously, we can also extract the data type out into a generic function and then a generic type, and they can operate on any type, right? This is, I think that's all I wanted to cover. Where do we take this? Like, what's the use of that? I've seen a couple of libraries Yeah, go on, please. Is there a question?
No, I don't think
Alright.
there is yet.
Yeah, so I've seen this use something like the next step for this would be, if you're interested in this kind of stuff, then I would request you to kind of check out these two libraries. One is FPGo, where they've built like functional programming helpers by Golang generics, right? And you can look at the filter here, the one that we just implemented. This is kind of exactly how it works in some way. Here is the predicate. They call it a predicate instead of a condition, which is the correct like FP way to call it. And like here is a sort of a list of predicates. Yeah, filter actually takes just a single predicate and then it works on the list of t's. In their case, the t is int, so it's a list of ints, and you get back a list of ints. So this is how the generic function for a filter would look like. They've implemented filter with index, slice, and whatnot, but you can imagine implementing something similar for other function types, which are imagine like map, filter, reduce, flat map, etc., which is what you will see over here. There were also composition of functions in some way. I haven't used this library in production, but try to tinker with it and play with it for some of the other like small stuff that I do, not on prod. So I'm not sure how good it would hold up in terms of memory usage, etc., when it comes to production usage. But for tinkering with stuff, pretty good library to try out. Apart from that, I think the next even bigger thing would be to, if you like manipulating data using functions and functional programming in Go, then you can also look at Go streams, which takes it to the one notch above, and it talks about stream processing, not just in-memory processing. But imagine like a infinite stream of data that you're handling. How would you handle that, and what would it look like? So it has connector, it has modeled like source, flow, and sink as data types or as structs, and then these are I think interfaces, and then each of them are implemented using source, flow, and sink mechanism. So you have various supported connectors, like you can connect to Kafka, you can connect to NATs, Redis, go channels like read from files, standard out, etc. And just to show you one example of filter, here is like the input stream, which is a channel of interface, which is like any type in Go. And this is the output. So you would take something in, you would put something out, and you can run the predicate as a filter in the middle. So this is the visualization, like you get 1, 2, 3, 4, 5, and let's say you drop 3 and 4. So you get 1, 2, and 5. So that's the filter predicate that you write, right? It works in a streaming fashion. You can even set parallelism where you can have multiple Go routines run each of these. So this library is pretty good, pretty cool. And the way they've done it, all the magic happens in this simple like 15-line do stream function. Super amazing. Super geeky to look at. So that's something always worth looking at. All right. Yeah, that's it from me. What I've been doing apart from that, just want to quickly talk about is this whole bootcamp. I'm currently working on it. I've made it public. You can take a look at the website, playbook.12, and it's all on Notion right now. I'm looking to add more examples and more real world like stuff there. So keep an eye out. All right. I know it was a short one, but yeah, that's it from me.
Thank you.